that's working again. So anyway, just wanted to show that if you are absent and you don't have a chance to come grab the packet, you can always look in Skyward and see which assignments have been given, when they're due, and then you can download it if you need to. Questions about that? The other thing I haven't really pointed out is if you are absent, let's go to here. Hey, I have found that most students really struggle if they miss this class because the learning all takes place via the discussion. And so if you know you're going to be absent due to a family thing, school thing, whatever, if you happen to have a free period or a lab period, you can come to this class instead. I've had people do that quite a bit over the years, where they know they're going to be absent A2, and so they arrange to just come a different period. The only thing you have to be cautious about is, for you it's easier because you're A day, you can come any other A period or any B day period. B day students would have to make sure they came either a different B period or the day before. But you can do that.
Do you teach calculus every period?
So I have calculus every single period except for A3.
Alright, so because I have a free period before, so that work?
Mm-hmm. Absolutely.
Okay.
Oh yeah. I even had some students who said, I went to my regular class A2 and I just felt like I really wanted to hear it again because it just wasn't quite clicking. They just come again, and you're totally welcome to do that. So the other thing you can do that is also proven to be very helpful in past years is the videos, like the video that I'm making right now. It's not really a video. Like all you see is what happens here. There's no camera in the room, but the microphone does pick up the audio, so you can hear the discussion. And so if you're sick, you had no way of planning to miss, or if your schedule just doesn't allow it, it doesn't work to come like after school and say, oh, I missed class, can you help me? Because there's just no way for me to do another hour-long discussion to help you get caught up. So what you do instead is you just go to the website. You can get this through the school, but that's kind of slow. It's faster just to remember the name. Since I was really fortunate, I did this long enough ago that I get to have my website be called craigbsmith.blogspot.com. So it's a super easy address. Click on Unit 1. So far there are 3 days of videos loaded. Today's the 4th day, I didn't count the introduction day. And you just click on it. And I don't have the audio turned on, but it just jumps to YouTube, and you see everything that happened on the board and you hear the audio. You can stop, start, play it slow, whatever to help, okay? So if you miss class, do this. Like study the video thoroughly, and then try to do the homework that is assigned that day, either by coming to get the packet or downloading it. If you are struggling, then come in and get as much help as you want. Like once you've gotten through the video, then I can really help you a lot before or after school. So, any questions about any of that? Awesome. Okay, back to the homework. As I walked around the room, the biggest thing I seem to be getting from this class is there was a fair number of you who felt like you got through most of the homework, but you felt a little bit like, I'm not really sure I'm really understanding what I'm doing. I kind of feel like I'm getting the right answers, but Mr. Smith keeps telling me that I've got to make sure my understanding is good. I'm feeling a little nervous about that. I think the best thing to do at this point would be to simply have one of you who has tried to get through a problem, felt like it didn't quite make sense, raise your hand, suggest the problem, we'll talk about it, and kind of go from there for a minute. So I want to talk a little bit about the homework before we do anything new. But so you have a specific problem that they felt like just wasn't quite as
25.
25. Okay. What what I'm going to do on 25, I did this last period as well. The same question actually came up, exact same problem. No, somebody else asked. He may have had the same question. Okay, I'm going to give away a whole bunch of extra credit today, but I need you participating. Because what I'm trying to do is sense, are you understanding or are you just copying me? Okay? So here we go. Because I've got to make sure, like, limits are important, but what are far more important than limits are some kind of more fundamental ideas that you're really supposed to bring with you to this class, but I kind of find most people don't. Like, they just lose track of these fundamentals. If you can keep track of the fundamentals, the rest of the year is much easier. So here's the first question for the whole room. As I ask these questions, here we go. This says the limit as x approaches a of this. Okay? First question I have for you. Here's a formula. And some of you have been coming in for help, have heard these questions. I don't think I've done it in class that much, so I'm going to do a little bit today. Okay, all year long, you're going to be given formulas, functions, and you have to keep track of what I call the fundamental purpose of this formula. Okay? So I need everyone in the room who knows what the heck I'm talking about to raise your hand and tell me, what is the fundamental purpose of this formula? I don't think I have done anything yet, Clark. So thinking. Canyon knows. Anybody else know the fundamental purpose of this formula? This fundamental purpose will not change all year long. You must keep track of it. I've literally had times in April when we're working on the AP test, and students will say, I'm stuck on this problem. And all I'll say is, well, there's a formula right there. What's its fundamental purpose? And they go, oh, I'm not stuck anymore. So, hands up, who knows? Extra credit for all we know. Let's go, Dawson.
Just find the y value.
So this formula is to find the y value. How many knew? Point. You plug in an x coordinate, you run it through the formula, you find a y coordinate. Okay? That's its purpose. Don't forget this as well, though. You're going to encounter problems in the future whether you have to do that backwards. They'll tell you, hey, here's the y value. Go find the x that created that y value. This formula can be used for either one. So I'm probably going to ask this question multiple times today and multiple times in the future. When I say what's the fundamental purpose of the formula, you have to tell me it's to find the x's and y's, the x-y pairs. So a table like this. So what Dawson said is, well, if x is, I don't know, 7 or something, we can plug in the 7 and find the y coordinate. And what I said a minute ago was, well, what if they tell you the y coordinate's 21? Well, that's a pretty complicated formula, but with a calculator and some help, I can find the x coordinate. Because they always come in pairs. They always come in pairs. Questions about that? Cool. So we'll get to the limit question in a second, but raise your hand if you can answer this. If this thing is meant for plug in an x and find a y, how many x-y pairs can be found using that formula? Raise your hand if you know. Lots of extra credit, you just have to raise your hand. So how many x-y pairs can be found using that formula? It feels like a trick question you're probably understanding. You just need to raise your hand and answer it. So how many x-y pairs can be found using that formula, Elena? So Elena says an infinite number can be found. Please raise your hand if you agree. Point. Your hand is raised. You can find an infinite number of xy pairs using this formula. That means this list, for most things we deal with in this class, say it out loud. How many items are in this list? Infinite. Okay? So this is kind of a dumb question, but I just want to give away some more points. Please raise your hand and tell me. Well, if we can make a list of the xy pairs, why do we use a formula instead? Like, why not just make a list of the xy pairs? Hands up. why not just make a list of the XY pairs? Why deal with a formula? Larissa?
It's too long.
It's too long. Challenge each of you to go home and make a list that is infinitely long. I'll check back with you about, yeah, never mind. How many knew that? Come on. Point. Okay, look. Based on how many people are raising their hand, it kind of feels like most of you are following the logic here, and maybe it seems simple, but if you lose track of it as you're working on a problem, it causes you trouble. So this formula finds all of these. Got it? There's an infinite number, so we use a formula instead of a list. Okay, on this, now here's something I have noticed people struggling with. As I go around the room, a lot of people seem to not quite understand, like, what was the whole deal with the horizontal asymptote part of the problem? Like, that felt fuzzy to a lot of people. Okay, it turns out to be really, really simple. When I say horizontal asymptote, I think it would really help if you wouldn't think this. Don't think, I mean, I don't want you to forget this, but I think it's kind of getting in the way. I say horizontal asymptote. I think most of you think this. You think of dashed lines that go like that. Okay? I think for our class it would be better if you don't forget that, but you would think differently. When you think horizontal asymptote, I just want you to think, oh, I'm just supposed to figure out if the x-coordinate has this value, what is the y-coordinate? And if the x-coordinate has this value, what is the y-coordinate? That's all you're doing. I'm not asking you to think of the location of dashed lines. I just want to know, hey, points for the whole room. Raise your hand. What's this for? What's its fundamental purpose? Some people are just very reluctant to raise their hand. That's okay. Chris?
Just to find the y.
Find the x and y. Don't lose track that it is for finding x and y, because you're going to have to use it backwards. How many knew? Four? This is for finding all the x's and y's. Horizontal asymptote just means find what the y values are when x is really big, negatively. Find what the y's are when x is really big, positively. That's all it is. So it's not this. Okay, so that's O. And the other thing that I think is complicating, making it hard for people is if I figure out that when the x-coordinate is this, the y-coordinate appears to just be getting more and more positive forever, that is not a horizontal asymptote. That's just telling me how the graph behaves at these x-coordinates. Okay? But if I do this work and I find that when x is very, very negative, the y value turns out to be 7, then we say there is a horizontal asymptote of y equals 7.
So if y is in infinity, it's not a horizontal asymptote, but if it gives you like a number, then it is?
Right, because what you're finding, Justin, is this. You're paying attention to the graph again, and you're just noticing that every time you pick a larger x value, the y-coordinate is here. When I pick another x value, the y-coordinate's even bigger. Pick another x-coordinate, the y-coordinate's even bigger. So you find that every time I pick a bigger and bigger, that would be down here, bigger and bigger x-coordinate, just keep getting bigger and bigger y-coordinates. Well, this is not the type of thing you see when there's a horizontal asymptote. I joked last period, this is not horizontaling. It's not becoming horizontal, okay? It's going up. It's upping. Weak jokes today. So that's no horizontal asymptote. But if your analysis says when I pick larger and larger x values, I see this kind of a pattern. Oh look, they're kind of coming out to be about the same. And that number turns out to be 1/2. And you'd say, yeah, that one has a horizontal asymptote of y equal 1/2. Question? Be honest with me. If you got to get a sense of where we're at, I can't quite read the class right now, so I need you to vote silently without showing everybody else. If you feel like prior to the last few minutes, all of this made perfect sense when you walked in the room today, do this. If this is helping you make better sense of what we mean by horizontal asymptote, do this. Show me. This is a worthwhile discussion because I'm getting probably at least half of it doing this, so that's good. Okay, good. So one more time. Please stop thinking of horizontal asymptote as, horizontal lines. Think of horizontal asymptote as, I've just got to figure out what the y coordinates are when the x coordinates are either very negative or very positive. Someone asked when I walked around the room, they said, well, are we always supposed to check this? On this packet, yes, for practice. On the AP test, not sure. Depends on the problem. So, questions about AP? Please.
So how do we find the horizontal asymptote from that formula?
Up here?
Yeah.
Awesome question. Let me get some water, sorry. So, a key to this class, key to calculus, is keeping straight the difference between a concept and a procedure. A huge mistake students make is they tend to drift to procedures all the time. Like they lose track of the concept. They're like, hey, I got through all the homework, and as soon as I start asking questions, they can't answer the questions because they've done the procedure without any understanding. That's really dangerous. So Elena's question is very valid. Did I give you the zoo analogy already? Yeah. Every time I do this, I feel like I'm the panther in the zoo. Okay, cool. What's that? The Pink Panther. Interesting. I have had people say that I resemble Steve Martin. So. I dressed up like Steve Martin one time for Halloween. It's reasonably better. Okay, Elena's, say your question again. The drink got me all distracted.
How do we find the horizontal asymptote?
For this, right?
Yeah.
Gotcha. Okay. Vote again. This means I'm totally confident. This means I'm just trust your feelings. If you trust your feelings in this class and then you do something about it, you'll be successful. Like if you trust, I understand it or I don't understand it, and then you come in and talk when you don't, you'll be fine. If you don't trust your feelings, you're going to get in trouble. Now that I've tried to explain horizontal asymptote in a different way by illustrating this, this means I'm feeling really pretty comfortable about what horizontal asymptote means. I still just do not feel comfortable. Show me.
Sounds like do this if you just understand
This is like
what it means.
feeling good. I'm feeling good. Like, no, different question. Good question, Justin. Yeah, hands down. I'm not asking, do you know how to find it? That's different. That's the procedure. Okay, I'm asking, do you understand what it is? And like what they're asking. Because to me, when they say horizontal asymptote, my brain says, oh, I have a long list of XY pairs. I'm just supposed to figure out what are the Y values when these are the X values. That's all I'm supposed to do. How I do that is the procedure. That's different. The understanding part is what I'm asking about. How many are really comfortable, you do this, still uncomfortable? Show me. So I got still a few people who are uncomfortable with the idea. So somebody who's comfortable with the idea, raise your hand. I'll pay you a full ticket to share with the class how you would describe What the heck are we talking about when we keep talking about this horizontal asymptote idea? Josh?
I think it's kind of like when you have the dots right here, like the blue ones that I think the horizontal asymptote is just like where it kind of evens out, where it's, instead of goes from going really up and down, kind of being volatile, to just leveling out and being like along the same number. The y coordinate stays the same for all those x's around at that point.
So the key thing, I like what you said. You said, okay, if I get over here, what x coordinates are we dealing with over here, John?
Bigger.
Unbelievably big is the idea. Unbelievably big. And as we get to these really big x coordinates, you said it well. You said, hey, if the y coordinates are doing this, I do not have a horizontal asymptote. But I had to go check. If the y coordinates are doing this, I don't have a horizontal asymptote. If the y coordinates do this, I have one. Here's another thing the y coordinates can do. Okay, I'm trying to draw something that oscillates forever. But as it oscillates, it gets smaller and smaller. So I need you to vote. If this y coordinate right here, actually, does this function appear to have a horizontal asymptote? Yes or no? Go. Yes, no. If it does this, it goes up and down, and then over time it just gets tighter and tighter, but it goes up and down forever. It never stops going up and down. Is that a horizontal asymptote? Yes or no? Show me. Everyone gets a point for trying. Here's the answer. Look at the board again. Think of what Josh said. He said, we get over here to really big x's. We just look at what the y's are doing. If the y values, listen close, if the y values are like climbing, no horizontal asymptote. Y values are going negative, no horizontal asymptote. If the y values in some fashion are getting close to something, that's a horizontal asymptote. Common ways for that to occur would be this. The graph might just kind of go like this and get close to some y value. The graph might do this and get close to a y value. The graph might always be that y value. It never changes. It's just always that value. These are all examples of horizontal asymptotes. The one I gave you is also an example. If the graph does this forever, that's still a horizontal asymptote. Because as x is way over here, the y values are getting very close to becoming a single value. Questions? Oh, Josh, it's in there. Vote again. Really comfortable with horizontal asymptote? Still not quite comfortable, be honest. If you're not comfortable, it's totally okay. Okay, somebody else can take it to say it differently. Or just say it in your own words, or even say exactly what I said. Chris?
So I like to think of it like this, like just the horizontal like asymptote will just say is my super smash level, like my ability. Let's say Josh wants to beat me. He might spend infinite hours. He might get infinitely close, but he'll never beat me at Super Smash.
Fair enough.
It's probably true.
One thing I would add to that, please memorize this. Okay, actually everyone's going to vote here. In this case, the y value is getting very, very close to equaling, I'll say 3. In this example, just raise your hand if you know the answer. Is the y value ever equal to exactly 3? Raise your hands. Come on. In this case, what I'm saying is it goes like this. And it gets like a little more than 3, a little less than 3, a little more than, it's like getting closer and closer to being exactly 3. Does it ever actually equal exactly 3? Hands up. Come on. Who knows? Charles.
Yeah.
Crossing. It's like above 3, below 3, above 3, below 3. It's equal to 3 an infinite number of times. That is still a horizontal asymptote. So for those of you who have in your head that horizontal asymptote can't be touched, wrong. Okay? How many knew this? 2 points.
No, I feel like because that's what they taught in math last year, because it's like, you'd always use the graphs and they're like, you can't cross this line.
Right.
That's why I feel like people are like, when there's this horizontal asymptote, they can never equal that number, so they're always like, that's not right because it touched it.
No, Justin's got that perfect. You kind of have in your head, here's the horizontal asymptote. The graph will only do this kind of thing. It'll never touch. Lots of functions do that. Lots of the functions we're talking about do that.
But I feel like if it does touch it, then it's no longer a horizontal asymptote because they touched it.
And that's wrong. There's nothing, you can touch it all you want. Okay? Like this example here, it touches it an infinite number of times. Questions? Sydney, please.
Wait, so the way we find out a horizontal asymptote, like from this homework, is we get like the biggest variable from the bottom, or is that for the x is closer to infinity? Like,
Oh.
I guess when
No,
I'm-
really good question.
Yeah.
Just pause for a second. Sorry, lots of extra credit today. Full ticket, outstanding question. Everyone else who can answer a question can also get some extra credit. What she said was, it's perfect. She said was, okay, feel like I'm starting to understand what we mean by horizontal asymptote. Fair? So now you're moving from the concept to the procedure.
Yeah.
But you're still kind of over here in the concept a little bit. She said, well, wait a minute. When I'm finding the horizontal asymptote, what am I supposed to do? Or, wait a minute, we did those problems where we found the limit as x approached infinity. And you kind of said, is that is that different or is that the same thing? Like when I'm doing this, okay? Let's hold that question for just a second. I want everyone to answer this. What in the heck is the purpose of this blue box? Come on, hands. Christian,
To find the x and y values.
how many knew it? Point again, keep marking them. That's how we find the x, y values in the list. Hands for the whole room. Make sure you get the extra points when I say your name. Hands for the whole room. What does it mean to find a limit? See, like, look at the room. This is exactly why we're having this discussion, okay? Is it does no good on the AP test to be able to do the procedure if you don't understand the idea. And so when I ask the idea, you can tell the whole room just kind of goes, well, I'm not sure. So what does it mean to find a limit? And it is super simple once you can get it to click. There's no way to get it to click unless you just keep talking until it really does click. What does it mean to find a limit? So Abby?
As x approaches a value, you're trying to find what y value it approaches. So usually it's a value that you couldn't just normally plug in, so you can't plug in infinity because there's no just number for infinity. Or a lot of the numbers that it is, like you can't plug into it because it doesn't really work in the equation. But you could technically do it with a number that did work in the equation. It would just, instead of approaching it, would equal it. But as an approach, it would still approach it.
You said that really, really well, Abby. I'm going to say it back to the room. I'm just going to take a little piece of what you said. To me, the most important part. When they ask you to find a limit, all they're asking you to do is to take this formula and plug into that formula an x-coordinate that is almost a. That's all they're asking you to do. So over here on the table, just doing what Christian said, I can say, hey, let's just plug in a and see what we get.
Also, limit is.
But they don't want you to plug in a. Abby mentioned that. They want you to plug in a number that's really close to a. 1 second, Justin, sorry. Okay? That's what they want you to do, and that's it. That's all a limit is hey, the x-coordinate's almost a, what's the y-coordinate? That's all they're asking for. Justin, please.
So what's the limit? It's a value right before y that they're trying. How would I write down my notes just I know I can read?
I would just write that this means for this x-coordinate, find the y-coordinate. And for this x-coordinate, find the y-coordinate. That's all that means.
I meant for limit.
Oh, that's what it meant. This whole thing.
Okay.
Good question, Justin. When they say find the limit as x, points for the whole room. Raise your hand, please. When they say find the limit as x approaches a of this, how many x coordinates are they asking you to think about? Hands up. Better answer would be like how many, well, no, how many x coordinates are they asking you to think about? Let's go, Mary. It really is infinite. Like they want you to think like closer and closer and closer, but that gets kind of hard to wrap your head around. So I kind of simplify it, Marion. I say they're kind of just asking for two. The one that's a little bit less and a little bit more than a. They're just asking for two x coordinates. Okay, you raise your hand and give yourself 2 points. Okay. When they say find the limit, they're saying go to these two x coordinates and find the y coordinates. That really is all that means.
All right, so limit just means it's like find the points that are close to this point almost.
Yes.
Okay.
For these two x values, find the y values. It all comes back to the list. When they say find the limit, they say for these two x values, find the y values. Points for the whole room. When I say find a horizontal asymptote, what are they asking for? Again, short answer, Kyler.
Is it just the value that like it keeps getting closer and closer? Not closer to, but like it closer to, but like crosses over, like.
Hard to say. I get it.
Like I don't know, like.
I totally get it. Hard to say. So 2 points for Kylie. Let me say it in hopefully a way that is easier to remember and easier to repeat back. When they say find this limit, I say, oh, we just go to these two x coordinates and find these y coordinates. That's it. End of story. When they say find a horizontal asymptote, we just go to these two x coordinates and find the y coordinate. That's it. We just go to really big X, either negative and positive, and find the y. If the y turns out to be infinite or negative infinity, then there is no horizontal asymptote. If the y turns out to be 7, then there is. So when X is really big, if the y coordinate's 7, we're done.
And so then when we're finding, because for the most part, it was x to infinity on the homework. And so basically, when you want to double check it with the negative side, because you have to compare the two numbers, do you just make them both negative?
Kind of depends on the problem. We'll do that in a second. That kind of varies, Justin. But I was trying to get back to what Sydney said and why he gave her a ticket was, I was hoping all of you would, after getting through this packet, would quickly recognize, if they say find the limit as x approaches infinity, they're just saying, here's the x coordinate, tell me what the y coordinate is. That's it. Which is exactly the same thing as saying, find the horizontal asymptote. There's no difference.
So if it's going to, if it's like the limit that's x to infinity, you'll have the same answer for your like answer to infinity as well as the horizontal asymptote.
There's no difference.
But then if it's like a number, like x to 2 or x to a, then it would be different.
Correct. Because if they're asking the limit as x approaches 2, in this table, they're not asking for what's happening here. That's what we talk about when we talk of horizontal asymptote. They're asking what's happening here. So, good job, Sydney. Please, Julia.
When you plug in a number to find, like if it's x approaching a number, this is one thing I kind of struggled on homework. So when I factored it all, we kind of during class, we plugged in a number that was close to it, but it kind of ended up being that number. So if it's x approaching 0, can you just plug in 0 once you've factored it as much as you can? Can you just plug in 0 and then solve?
Let's do this one a little bit more and answer that question. So what's your question, Julia? Other questions? That one's going to come out here. It's a good question. Okay, let's go to work here. Okay, I feel like we have a pretty good understanding, better understanding now that the purpose of the blue box is to find all the xy pairs. When they say find the limit as x approaches a, they simply want you to figure out, for these two x coordinates, what are the y coordinates? Everybody with me? When they say find the horizontal asymptotes, they're just saying, for these two x coordinates, find the y coordinates. That's it. Don't think of it more complicated than that, really. Okay, that's the concept. Now the procedure. Turns out that we really have only learned 2 procedures. One, if we're trying to figure out what happens when x is big, we can compare things that are adding. 2, if that doesn't work because x isn't big, x is just a, we factor. That's really all we're doing. But when we factor, we're trying to find a way to divide. So you want to factor intelligently. Please, just.
So when x is approaching infinity, you just compare.
You're just comparing things that are adding.
Okay, and then when you're getting to a point, then you factor. So
Then
if
you
the
factor.
x approaches a or x approaches 2, it doesn't matter, but you just need to
Need a factor.
Okay.
Yep.
And that was like on like the, like your steps for the limit problem, like 1. Yeah, like
No, it's perfect, Josh. That's why I said on the steps, first thing you check is the limit x approaching infinity? If it is, we're going to compare things that are adding. Otherwise, we're going to factor. Okay, so here we go. A quick review of factoring, because I still see people having trouble with this as well. Look up here, points for the whole room. Okay, when I look at 10x to the 4th, that's a term, because it's being added to this term. But it's a term that is made up of, it's comprised of, in my opinion, 6 different factors. Raise your hand if you know what 6 factors I'm thinking of. Like what 6 things get multiplied to create 10x to the 4th? Waiting for a hand. That was a hard question apparently.
6 things per variable?
Just 6 things. So again, whatever, 6 things that multiply to become 10x to the 4th. Zach.
5, 2, and then x times x times x.
So Zach sees 2 times 5. Oh, there you go. 2 times 5. I'm going to sound very egotistical here. I think I'm a lot better at calculus than you are. Dumb statement. I'm just more experienced, to be honest. But my experience has been if I think this way, it helps me. Like if I think of this as 2 times 5 times x times x times x times x, helps. How many saw it? 6 points. Don't ask me why I just gave you 6. Whatever. 6 was on the brain. Okay. When you're factoring, do simple factoring first. So you look at it and you say, okay, I see the factors. I look over here, I see 6 things that are being multiplied here as well. You're looking for things that are common. So both of them have a 2, both of them have a 5. I am only going to pull out the 5. Who knows why? Like they can pull out the 2, but I'm not going to. Why am I only pulling out the 5? Ashley.
So because you can pull out the 5 on the bottom too.
How many knew it? Point. Ashley's correct. I'm trying to find something I can divide. So I pull out the 5 on the top. That leaves me with 2x to the 4th. Factoring's easy. Look, I just pulled out one of the factors. Just write down the ones that are left. Same on the bottom, or similar, I should say. Questions? Okay, so again, we started the problem by trying to get everybody in the room. Because look, I just want all of you to be successful in May. All of you. So we start off by saying, what's the idea? What are we doing here? Trying to find a limit. All we're doing is trying to find out what happens at these 2 x coordinates. You know, technically it's what Marin said. It's infinitely closer and closer, but that's a little hard to think of. So shortcut. What's happening here? Now we're on the procedure part. We're factoring. Questions? Marin, please.
So when I did it, I didn't factor the bottom. I just took the 10 out of the top, and it just like made me do like another, like I had to factor it one more time. Is that okay?
That's okay. Yeah, I think you're fine. I'm going to keep going. I'm going to factor again as well.
Okay.
You good to hear? Please raise your hand and tell me, what is the purpose What's the purpose of the blue box? Show me hands. No, it's getting tedious. Aisley. Find the XY pairs. How many knew it? Point. This is raising your hand practice. Get some dumbbells and make it double. Lauren laughed a little bit. You have a very sophisticated sense of humor, I can tell. So. You good here? Raise your hand. Is this the same as this, or are they different? Hands up. Are these the same, or are they different? Luke?
I mean, they're basically the same. They give you the same thing.
They look different, but they're the same. How many knew it? Point. Cool. Oh, here's a good question. Why change then? Like, why do we? Like, I don't like to factor. Okay, I'm not a mathematician. I'm an engineer. I like to go home and build things. I bought a welder. I'm excited to go and build something. Like, I don't like factors because I think factoring's fun. I don't. Okay. So why go to the word? Like, why are we doing this? Kenyon.
To make it easier to find the y value.
That's the whole idea. If I try to plug in these two x values into this, it's back to Julia's question. That's not easy. I'm trying to get to where it's easy. Okay? That's the whole point. Let me do it. Point. So we keep going. So this becomes this. Oh, here's one. Look. Have I explained this in this class? Okay. Don't ever do this. Don't ever say, oh, we just got to cancel some stuff. So let's see. Well, there's an x to the fourth, and there's an x squared, so that just leaves an x squared there. There's an a to the fourth and an a squared, and that leaves... Don't! I have some handcuffs in my drawer. If you do that, man, I'm coming out here and like clamping you to the table. It's illegal. Y'all look at me like it's legal. It's not. Okay? Look. If you have been doing this in past years, you got lucky. Congratulations. Okay? It is completely wrong. You're still looking at me like you don't believe me. Okay? It is wrong. Look, it's completely wrong. The only time you can divide is when you're dividing factors. Okay? So, for example, let's get rid of all this mess. Thank goodness for the undo button. Yes, no canceling. People think, oh, there's the mathematical operations: addition, subtraction, multiplication, division, and canceling. Okay? Canceling is not a real thing. Oh, getting to okay. Canceling is not real. Look over here. Come on. Focus. You can only divide factors. Raise your hand if you know the factors of that numerator. I'll give you a big hint. There's only two. Who knows the factors that comprise that numerator? There are only two of them. What are the factors that comprise that numerator? This is a really good discussion because the questions I'm asking you have all got to know. If you don't know them, that's fine, but you got to learn them. Like, this is crucial for this class. What are the factors of the numerator? Very few hands on this one. There's some more. Let's go, Julia.
Is it 5 and 1?
2 points, but no.
Okay.
It's okay. Wrong is no problem. Just got to keep talking. Sarah, sorry, Natalie got me. Sorry.
Is it X and A?
No, 2 points. Let's go, Kennedy.
5 and 2.
2 points, but no. Okay, let me say it back to you. Hands down. Okay, factors simply means this. You have a numerator, right? Factor means what are the two things that are multiplying to be the numerator? To make the numerator. Let's go, Rachel.
Is it 5 and then like the parentheses?
Oh, I love how you said that. It's 5 and stuff. Right? Nobody wants to say all that. It's like 5 and this, right? 2 factors, that's it. You can only divide factors. So you can't be dividing these. They're not factors of the numerator. can only divide the factor. Here's why. Sorry, getting a little excited. Look. Hey, when you have a fraction that's made up of things being multiplied, you can split it. You'll see me do this all the time. This becomes 5 over 5. 2x to the 4th, subtract 2a to the 4th. X squared minus a squared. I can split them. Because how do you multiply fractions? Top times top, bottom times bottom. So this times this is this. This times this is this. So when you split them, it becomes easy to see why they divide. These divide to make 1. Canceling is not a real thing. Don't say that word. Divide to make 1. I have a stick over here for those who like to say the word. Good. Still functional. Okay. Don't say that word. Okay. So this divides out. I got a little excited. Is everybody with me? Yeah. Awesome. So here. This is all on video. Great. Okay. Wow. So now we have this. We're kind of using this way. Okay. I'm kind of taking a lot of time to get the detail. Points for the whole room. Hands up. What's the purpose of that formula? Rachel.
To get a y coordinate.
X and y.
X and y pair.
So to find the xy pairs, right? We're looking for these two. How many knew it? Point. We started with this blue box. We've gone to this one, and this one. Just say it out loud, please. Are they all the same, yes or no?
Yes.
Yes. They're all the same. We're just trying to get to something that's easier to use. Well, I still don't find this very easy to plug in these values. There's just too much going on. So I keep going. I factor again. Now it's a difference of squares. So Justin, please.
At this point, so say instead of just having a as a variable, could you just plug in the number if you wanted to right here?
If you plug in too soon, here's what will happen. You get 0 on the top. You get 0 on the bottom. Your brain says what when you see 0 over 0? 0. Yeah, your brain says 0. And on the multiple choice test, guess what one of the answers is?
0.
0. Is that right or wrong? Say it.
Wrong.
Wrong. You can tell by my voice, of course, right? That's wrong. They're trying to get you to do that. Here's another one people do. Some people remember that 0 over 0 actually is not 0. It's undefined. They look over the multiple choice answers. One of them says non-existent. Is that the right answer or the wrong answer? Wrong answer. Okay? You can't plug in too soon. Plus, you're not really plugging in A anyway. And like I said to Julia, if we try to plug in close to A, it's just too hard mentally.
No, I meant like instead of like a, because like on some of the questions it gives us like 2 or 0.
Same thing. If this were 2, then this would be 2 and this would be 2. You're still going to get typically 0 over 0. Yeah. So we factor again. I'm running out of time here.
So you basically want us to get down to when we can't factor anymore and then plug in.
The hard answer is not necessarily.
Okay.
Hey, give Justin a better answer. Look. You don't have to factor every problem to solve them. It depends on the situation. If you're trying to find the limit as x approaches infinity, you typically are not factoring. Sometimes you might, but not typically. If you're trying to find the limit as x approaches, say, 0, you usually have to factor at least once, but you don't necessarily have to factor after that. It's all a matter of getting good at recognizing, can I really plug in this, not A, but this number and understand what's happening? To me, there's too much going on, I can't. But if I go one more step, pull out the 2. Once I pull out the 2, I'm going to have a difference of squares. So I'm going to factor that. Okay.
So you took the 2 out and then you split up. And then you, okay, yeah, okay.
Good question, Justin. Hands up. How many factors are in the numerator? Come on, hands. How many factors are in the numerator? How many factors are in the numerator? How many factors are in the numerator? Lauren says?
3.
How many agree? 3 points. How many factors in the denominator? Hands up. Like the denominator is made up of how many factors? Don't count 1, that's always there. How many factors are in the denominator? So Charles?
1.
How many agree? 1 point. Say it out loud, yes or no. Are any factors of the numerator also factors of the denominator? Yes or no?
Yes.
Yes, they can divide. They don't cancel. They divide.
Could you say cancel? I meant like not you're not actually canceling, but like it just turns into 1.
Can't you cross it?
No, you're not canceling.
Yes.
They divide to make 1.
So every time instead of saying they cancel out, you want us to say they
divide to make 1.
God.
Please,
Maybe
please.
still slash it out.
No. No.
Me writing
It's not visually satisfying.
It is though.
What if it's that's my way of writing 1? There you go. Just cross it.
You guys are, oh my gosh. Okay, here's the other reason why you don't want to say cancel. You will see me do this, that's common, because that looks like a 1.
Right.
Okay, look, we're almost done. I need to say something before the bell rings. Listen, folks, everybody look at me. Okay, I know this took a long time. I had the other packet right here, ready to go. Okay, but I am so uncomfortable. Don't go when the bell rings. I am so uncomfortable with ever just, okay, time to move on. Half of you look half lost, you know. Okay, I can't do it. Like, we have to stay on a bit of a schedule. We just have to. But I teach a lot on my gut feelings of like, this doesn't feel like you're really understanding. And this stuff happens all year long. You've got to make sense of it. So no homework tonight, okay? But you've got to get this done if you're not. And if you're, don't leave. And if you are honestly looking back on it saying, I don't think I understood that as well as I should have. Like, spend some time, make sure it's making sense to you. Okay, one last comment, don't leave. Here's why we don't cancel. This is equal to 1 for all values of x except 2 of them. There are 2 values of x that this does not equal 1. Because you don't want to cross it out. You got to keep track of it. If you plug in exactly a, this becomes 0 over 0. Just not 1. It's undefined. If you plug in negative a, it's undefined. So you've got to mentally keep track of that. So I do draw the line and say it's 1, but I don't ever say cancel.
Okay, so if
Good job, you go.
Plug in a, make it undefined.
Any value other than a will not be undefined, or negative.
So we figured out that
So is that our answer down
Yeah, the tables are kind of a pain. I have to put them all close together, they don't fit in the room otherwise. Okay, look. So these divide to make 1, unless x is equal to a, right? Good. So a question I didn't get to in class is, why am I okay to go to here then, if this sometimes isn't 1? Like, why is it okay to say, for our purposes, we'll call it 1? Like, why can I ignore the exception and go here? Anybody know? You're okay. Okay, so remember, this is equal to 1 unless x has a value of exactly a. It is not 1. So why do I just say, oh, it's 1, move on? Comes back to the big idea. It's not close to 1, it's exactly 1. When we're finding a limit, what are we finding? Here's the hints. Like when we are asked to find that limit, what are they asking us to do? X and Y pairs. Which one of the which X, Y pairs are we looking for?
The one
Closest to X equal A. So do we ever consider that X could be A?
No.
Not when we're finding the limit. That's why when I get way down here, I can say, for the purposes of finding the limit, this is always 1. So I can go to this. Okay, this is a lot easier to plug things into than any of all those. Because now I can do this. I can say, well, if X is close to A, think of it as being 5. So like close to 5 is 4.99999. If you plug in, if you take 5 and square it, what do you get? So what do you get if you take 4.9999999 squared? Something really, really close to 5. That's all you care. It's really close to 25, right? When you square it. So what if you take 5.00001 and square it? What do you get? Really close to 25. So if I take a number that's close to A, not A, but close, and I square it, what's it close to? Almost A squared. What's almost A squared added to A squared? Almost, gotta keep using those words. Almost 2A squared. Times 2 is 4A squared. So we figured out that for this problem, if you plug in exactly A, you get undefined. But if you plug in close to A, you get 4A squared. So that's the...
It's like on the graph, it looks like a little circle.
Right, the graph, did that answer your question already?
Yeah.
So on the graph, you're going to see when X is A, this is a Y coordinate of 4A squared. Okay? There'll be nothing here.
What is that called?
Removable, well, depends. Depends. Don't call it that. Depends.
Or it could be a jump.
Could be a jump, yep. For now, it's just a missing point.
Yeah.
There's nothing there. But right here, there's a point. Right here, there's a point. Those Y coordinates are 4A squared.
Okay.
If you guys need a note, I can write you on that. Oh, sure. So just go to the light. Well, we could do this. I think it might be easier if I do that. I'm afraid they'll like ask you a question. It's all complicated. Good job. You need a note? Yeah. You got 1 second. No, it's not hard. I'm just thinking. That's good. So I have a prep now. So what I'm going to do is I'm going to go get the book for you, check it out for you, because I can look up your student number. How that works too. Go to the cross. So I'll check it out, and then if you can just come by like just before 4:30.
Good morning, Matt. This is Calvin and Adam. Please stand for the Pledge of Allegiance.
Ignore that, we're just pulling this piece.
I pledge allegiance to the flag
And to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Okay, so.
Girls basketball open gyms on 8 after school starting September 4th. Any 9th through 12th grade girls interested in trying out for basketball should attend fall open gyms. Tryouts will be November 11th and 12th. For questions, contact Coach Warren. Congrats to our winners with yesterday's red and blue activities. Closest score guest winners are Monet Winger and Dane Tiny. They both guessed 14 to 31. They win free homecoming tickets. The drawing winners are Monet Clay, James Gatch, Jane Leroy, Landon Hancock, and Kate Mead. Please pick up your prizes in the front office. Are you interested in being a manager for the football team? If so, see Mr. Walker in the main office. The deadline to start a club is September 3rd. Come to the front office and pick up a packet in your...
I was looking at it and it's like, I know it, but I'm confused. This is gonna sound